In this video, I will show you how to use those parts to DIY a AC 220 volt or 240 volt to DC 12 volt and 12 amperes battery charger. This is a DIY transformer with a capacity of 170 VA. Its input terminals of 220 to 240 volt are here, and the output terminals are there. The one of options for the transformer's output is 13 volt and maximum 12 amperes will be used for this project. A double 3-prong rocker switch with a rating of AC 250 volt and 16 amperes is going to be used. A bridge rectifier of GBJ 2008 has been chosen for AC to DC. Together with a recycled heatsink, rectifier details are 800 volt and 20 amperes. This is a 12 ampere reset or cutoff switch, which is normally on, but switch itself off when the current goes though reach 12 amperes. These are the 12 different values capacitors parallel each other as the one. The positive terminal is here, negative is there, and this is a LED. The combination of capacitors values are 1350 μF and 50 volt. This is a DIY made resistor with 410 ohms and 3 watt dissipation. This is a mini digital voltage and ampere meter with DC 0 to 100 volt and maximum 10 amperes. A 3-pin socket for AC power from recycled electrical circuit board. Batteries positive alligator, negative alligator. The wires and wire connectors. That's it. All parts here will be connected together. Here we go. All parts or components have been connected for testing run. This double 3-prong rocker switch is fixed into a small panel for the convenience and safety. Red switch is for the AC power. That mini digital voltage and ampere meter is fixed into the panel as well. This is the circuits diagram for DC 12 volt and maximum 12 amperes battery charger. That DIY transformer is here. The bridge rectifier is there. The 1350 μF capacitor is here. A DIY made with 410 ohms resistor is there. The mini digital voltage and ampere meter is here. A 12 amperes cutoff switch is connected here. A DC 12 volt and 21 watt globe is connected there as a load for this testing run. This is the green switch. That is red switch. And they are here. Red is for AC power switch, and green is for DC over 10 amperes switch. We can see, green switch is connected parallel with digital ampere meter. The reason is that DIY transformer, bridge rectifier, and reset are all limited to maximum 12 amperes. But mini digital ampere meter is limited to maximum 10 amperes. So the meter would get burned if the current went through over 10 amperes. However, if green switch is installed, is on, and maximum current of 12 amperes reached, we are able to manage to let the mini ampere meter get through current just less than 10 amperes, and rest current go through green switch with its wires connected. In other words, divided some current from the mini meter. Those are the transformer's output terminals, which have been connected to the bridge rectifier's AC pins. These are the transformer's input terminals, which have been connected to the red one of double 3-prong rocker switches through wires for the AC power switch. Red switch is for the AC power on and off. This is a temporary bus terminals. Whole actual circuit with parts connected is ready for testing run. Switched AC power on, and DC current is 1.68 amperes. Switched green switch on, DC current is 1.38 amperes. According to the current values of 1.68 amperes and 1.38 amperes, a conclusion can be drawn. If the mini digital ampere meter showed 9.9 amperes when green switch was on, it would indicate total current reached 12 amperes. In this way, a problem for using small meters capacity in a larger circuit's capacity required has been solved. These are DIY-made semi-components for battery chargers case, which consists of a recycled steel sheet and 4 pieces of wood boards. The case has been assembled, and it looks like this, but the top cover yet. This is the case's top cover, with the double 3-prong rocker switch, mini digital voltage and ampere meter, and reset fixed into it. The parts, components and wires are going to fix into the case look like these. The double 3-prong rocker switch, mini digital meter, and reset have been connected, according to the charger circuits diagram. They can be seen at the back of case's cover. The DIY transformer is here. Bridge rectifier is there. A capacitor is here. A resistor is here. Terminals bus is there. There is another terminals bus at the bottom, and all things are connected and secured. Here is securing case's top cover by 4 screws. That is DC 12 volt outlet. And this is AC 220 or 240 volt socket. The batteries, alligators and cables, which have AT pins plug on the other end, to be plugged in DC 12 volt outlet. The AC 220 or 240 volt cable to be plugged in its socket at the bottom of the charger's case. The charger's negative alligator is not connected battery's negative terminal yet, and the AC power switch is not on. There is a sticker for the battery charger and a few things printed on it. This is for red switch, that is for green switch. This is for reset or cutoff switch. And that is for mini digital voltage and ampere meter. Turn the green switch on. If ampere meter shows 8.2 amperes, it means the actual current is 10 amperes. If ampere meter showed 9.9 amperes, it would indicate 12 amperes actually. That is reset or cutoff switch. The charger sticker stays here. Connecting charger's negative alligator to battery's negative terminal. Mini voltage and ampere meter is showing 12.8 volt and 0 ampere. This is battery's voltage only, because red switch for the power is not on yet. Switched red switch on. The mini meter indicated charging voltage was 14.8 volt, current was 2.46 amperes, and changing continually. Charging voltage is 15.5 volt, and current is 1.94 amperes now. This charging voltage of 15.5 volt appeared higher than it should be, because one of functions from a capacitor of 1350 UF installed in the circuit. Also that charging current of 1.72 ampere indicated was smaller than actual current, as previously explained. Switched green switch off. Charging current of 1.8 amperes indicated was the actual current. By taking the charger's negative alligator off the battery's negative terminal, the mini meter is showing no load values. Voltage is 18.2 volt and current is 0 ampere. The actual voltage value is 18.2 divided by 2 square root equals 12.9 volt approximately, because that capacitor installed in the circuit. Connected the negative charger's alligator to the battery's negative terminal again. Green switch is off. The charging current is 1.8 amperes, and slowly changing. All done, and this DIY battery charger is working well. Thank you for watching. Please like, share, comment and subscribe if you've enjoyed the video. Your encouragement is my motivation.